Then there are large number of load cells also. Strain gauge load cell is hydraulic load cell, pneumatic load cell, LVDT. So these are nothing but these are some of the devices that can be used for the measuring for the weight measure. So equal arm, one by one we people are going to see. So if you try to visualize a equal arm type of pressure measure, this is the force that has been exerted. So weight W1, weight W2, and when your weight W1 is equal to weight W2, at that time the scale is providing you a null deflection on the pointer. But here if you try to see your I1 or length 1 and length 2 both are equal to each other and both are suspended in a similar manner of a same material. So here it has been specified that weight 1 multiplied by product of weight 1 and length 1 is equal to product of weight 2 and length 2 generates a generates a null balance or null deflection which has been represented over here. So force exerted at this point and force exerted at this point depending upon the constraint are same are same. You people may have played a seesaw. In that particular seesaw, if actually here is one of the hinge and you are applying your weight or you people are sitting your weight and trying to move this one upward side, at that time this one downward side. When this one at downward side, this will try to move in the upward side. But what is actually happening with this particular aspect, if suppose this hinge is shifted from this particular point to this particular point, the length has been changed. And no doubt, as the length changes, length has been reduced. The minimum force is required to move minimum force at this particular side, and the maximum force will be required to this side because distance or the length has been changed of the device. Or you even can try at a home that using some spanner set by applying a force. So one you consider one nut and bolt, place one spanner set, increase the length of spanner. I will give the example when the driver of a truck is trying to release the bolts of the wheel. At that time he is utilizing a long spanner so that the force which is supposed to be exerted will be maximum on that particular place. Okay, so this is nothing but this is your actually equal arm type of balance scale, beam balance scale. Okay, so based on this particular aspect, you people are trying to measure the force that has been exerted or the weight that has been exerted. So when you people are going to say unknown weight is equal to W1, because W1 is known to you people, then L1 is known to you, L2 is known to you. You can easily determine weight when your pointer is representing at null position. Suppose W1 is 1 kg, and as you go on increasing W2, and when it rises to 1 kg, automatically this will become a balanced one. So force exerted on W1 and W2 will be equal. Okay, unbalanced, unbalanced beam balance this one. Okay, so over here I will try to move it to the downward side. So this is nothing but this is the scale. Here is your unknown weight that has been applied. This is the pointer which is indicated, and this is the calibrated scale. So what is this is the standard weight. This is the standard weight. You people can move this standard weight to on the scale. So what is going to happen? Unknown weight has been applied. If suppose this is less, this will try to move in the upward direction. If suppose this is high, it will try to move in the downward side. What you people are utilizing, this is the power arm. You will try to adjust the length of this particular standard weight in a such a manner so that it will become a balanced one. And this standard weight and unknown weight, when it becomes a equal, your pointer or scale will try to deflect over here. Your pointer or scale will try to achieve the calibrated one, or it will try to achieve the null position over here. Okay, so this is nothing but unbalanced. Actually it is unbalanced, and you people are we people are trying to make it balanced one. We are trying to make it balanced one. So how the null balance is achieved? So a standard mass or standard weight multiplied by a distance b, that is the length b, is equal to standard unknown weight w multiplied by the length of a. So we are interested, we are well aware that the we people are having the value of b, we people are having the value of a, we people are having the value of w1. So you people can easily determine the value of uh, w2, and which is nothing but b by a multiplied by w1. Likewise, you can easily determine the weight using this particular unbalanced arm beam balance scale. Okay. Then multi-lever. If you try to observe, similar concept is incorporated over here. This is one force you are applying. Here is the another weight. Here is the another weight. These are nothing but these are the different levers. Again, here your B, here your A. Then pan weight is provided, scale is provided. Then your power weights are provided. This is nothing but adjustable counterweight, and this is the tension that has been generated. So here is the force and these are the weights. So here the equation has been provided in such a manner that WB is equal to A multiplied by C divided by H multiplied by WS. Now what is this WS? That is the pan weight, or it can also be specified as a mass multiplied by WS, where M is equal to A I have specified over here, divided by B we have specified on the block diagram, multiplied by C is the total distance if you try to observe, and H is nothing but the moment, that is this H. We are not considering F, D and all that things for the multilever, but all these above mentioned parameters, depending upon the variation, you can even easily determine the weight WB. WB is the weight which is supposed to be measured, or the unknown weight that has been reflected. Okay. So likewise, you people can easily measure that resultant output using multi-lever platform. These are nothing but these are the multi levers, and based on that, we are trying to determine the output. Okay. So here you people can come to know the resultant output. The working principle is similar to that of previous one. Oh. So the another one is the pendulum scale. Pendulum. What is pendulum? Pendulum is nothing but this is the base, here is the ball, and here is the pendulum. In the other manner, you people can specify it one as a simple aspect. This is one of the jar and this is the pendulum. This will move in this particular direction. So that concept is used over here. So what is there? This is the sector, this is the support. These are nothing but these are the gears, and these are the counterweights. These are the counterweights. So what is going to happen? A unknown weight is applied at the bottom. The unknown weight is applied at the bottom. This will try to increase the force at downward side, and when it is trying to apply a force towards the downward side, it is going to create a motion across this part. This is going to create a motion across this particular part, and when there is a motion, this particular gear part will try to move in the upward and downward direction, trying to create a movement across your pinion and crank. So this pinion or pointer is trying to deflect the actual weight which has been generated by the unknown one, that will be highlighted over here. So it will try to represent the resultant output, how much, if suppose this unknown weight is you people are increasing, or equilibrium bar of the counterweight is unbalanced, at that time it is going to generate the output. So that particular output will uh, provide the motion to your indicator, to the indicator or pinion which we people are saying. So your pointer will move back and forth, either upward or downward direction, and the movement of the pointer will be totally depend upon the unknown weight which has been applied below. Okay, so this is pendulum scale. Now spring. So we people are having one spring, and commonly used for grass measurement nowadays. They people are using. We are applying a weight over here. We are applying a weight over here. Due to the applying a weight or a load or a force over here, there is a movement. So actual movement when the weight was not present is this position. After applying a load, it has been increased to x, means x displacement you people have got. So x is equal to force divided by k, and k is nothing but it is the stiffness of the spring, that is the rigidness of the spring, and actual accessory is like this. So what is going to happen when you are applying a weight at this position? This particular spring will try to move this pointer in the downward direction on the scale. So here you people are going to get the resultant output at this particular point, so that the output generated will be directly highlighted depend upon the load that has been applied or the force that has been applied. So force can be measured as a k multiplied by x, that is the stiffness, how much stiff is the spring. If it is hard, then it will move very little bit. If it is light in weight, at that time, depending upon the application, what application you people are going to use, depending on that you have to suggest. But commonly used device for the grass measurement in market to for the selling purpose. Okay, so this is your spring balance type of uh, weight measurement, or rather than that, even you people can say force measurement instead of weight, because that weight is going to exert a force towards the downward side, nothing more than that. Then another one is your strain gauge. We people are going thoroughly for this particular strain gauge, but I will just specify you. V0 is nothing but Vs is the supply voltage multiplied by R2. R2, all the resistance has been specified, R3, R4, R2, R1. These are the resistance, but what they are actually strain gauge. What is strain gauge? We will go thoroughly in strain gauge. But what happens, strain gauge is having the property, when you